completing the square. In this video, we'll learn the process of completing the square to solve a quadratic equation. The idea of completing the square is that if we can get the quadratic that we're trying to solve into the form of x plus n squared equal to a constant, we can solve that by taking the square root of each side. Since x plus n squared is equal to x squared plus 2nx plus n squared, we're going to manipulate our quadratic equation into that form. Watch. I'd like to solve the quadratic x squared plus 14x equal 38. It's not factorable. Negative 38 has two factor pairs, and their difference will not give me 14 in the middle. So this gives me a good chance to try the method of completing the square. I'm going to start by leaving a space to add a constant on each side. And since it's called completing a square, I like to draw a square for my constant. Now I'm trying to get x squared plus 14x plus something into the form of a perfect square trinomial. So what's going in the box will be n squared, and 14 is equal to 2n. So if 14 is equal to 2n, n is equal to 7. And I'm going to fill in this box with 7 squared. So x squared plus 14x plus 49 is equal to 38 plus 49, and x squared plus 14x plus 49 factors to x plus 7 squared, which I did on purpose. 38 plus 49 is 87, so now I have a perfect square equal to a constant. I can just take the square root of both sides, and I want to capture both roots of 87, so I'm putting a plus or minus there. The square root of x plus 7 squared is just x plus 7, and so that's equal to plus or minus the square root of 87. And finally, when I'm all done, I subtract 7 from each side, and x equals negative 7 plus or minus the square root of 87. Because the quadratic isn't factorable, I have an expression inside a square root as part of the answer. There's really two answers here. One is negative 7 plus the square root of 87, and the other is negative 7 minus the square root of 87. Let's go through the process of solving x squared minus 12x equals negative 23 by completing the square. The first step is to arrange the quadratic with x terms on one side and constant on the other. And I have that here, but I also want to leave a space to add a constant to each side. Next, I'm going to take half the coefficient of the middle term, that's negative 12, divided by 2, and square it. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36, and that's what I add to each side. Now I chose the constant 36 so that I could factor the expression in x to a perfect square, and it factors to x minus 6, the quantity squared. Notice that that minus 6 is the same as half the coefficient of the middle term before we square it. So that's a good way to just factor quickly. And negative 23 plus 36 is equal to 13. Now I can take the square root of both sides. Square root of x minus 6 squared is just x minus 6. And the square root of 13, I want to make sure I get both the positive and the negative square root, so I write a plus or minus in front of it when I take the square root. So x minus 6 is now equal to the square root of 13, and all that's left is to solve for x. So I add 6 to each side, and I end up with x equal 6 plus or minus the square root of 13. So 6 plus the square root of 13 is one solution, and 6 minus the square root of 13 is the other. We want to solve 2x squared plus 20x equals 15 by completing the square. We notice that the x squared term in this case is not 1 like it was in the previous two examples. So how do we deal with that? Well, this process is a lot about manipulating the equation to the form we want, so let's factor it out. The left side then becomes 2 times x squared plus 10x, and that's equal to 15. Now I can divide both sides by 2, and x squared plus 10x is equal to 15 over 2. Now I can complete the square. I take half the coefficient of the middle term and square it, and that gives me 5 squared, or 25. So I fill in 25, just like before, and the left-hand expression factors to x plus 5 squared. On the right, we have 15 over 2 plus 25, and if I get a common denominator, that's 15 plus 50 over 2, and that's 65 over 2. So when I take the square root, I'm taking the square root of a fraction. This is the square root of 65 over 2. The square root of the square is just x plus 5, and it's equal to both roots of the square root of 65 over 2. The square root of 65 over 2 is not in its best form. We'd like to rationalize the denominator, so I separate the square root into two parts and multiply the top and bottom by the square root of 2 so that I'll have a plain 2 on the bottom. The square root of 65 times the square root of 2 is the same as 65 times 2 inside the square root. If I subtract 5 from each side, x is equal to negative 5 plus or minus the square root of 65 over 2, which is the same as the square root of 130 over a plane 2. You can see that the process starts getting a little messy with all these fractions. And it can get even worse if what we factor out, in this case 3x squared plus 22x, 3 doesn't divide 22 evenly. So this factors to x squared plus 22 over 3x, and that's the thing that we need to complete the square with. Well, that sounds really hard, and in the next video we'll learn the quadratic formula, which gives us a much easier way to do it.